Good morning, good afternoon, or good evening, wherever you are. Hope you're having a great VMworld 2021. Welcome to the VMworld 2021 Hands-on Lab Guided Workshop for the Hands-on Lab 2226-01 NSX Security Operations Foundation. So this is going to take about an hour. You can come back and take the lab at a later time, but basically what we're going to do for you is walk you through a couple different modules of the lab that we put together this year. So we're going to do a quick introduction, kind of talk about the process where we go through and build the lab, go over the lab topology real quick, and then we're going to walk you through 3 different modules from the lab. So my name is Kevin Moats. I reside in Columbus, Ohio. I'm a VMware vCloud Networking and Security TAM. Been on the VCN-TAM team for over 2 years, been with VMware for almost 10. This is my 12th VMworld in a row. Before being with VMware, I've had the opportunity to go to a couple, so I'm pretty proud of that. And my 6th year as a lab captain. I like off-road riding, dirt biking, four-wheeling, jet skiing, snowboarding, just pretty much anything dangerous. And here's my motley crew over here. I have a 16-year-old son, Zach, a 13-year-old daughter, Olivia. Note the use of her boots and tippy toes. I'm really not that short. And then my girlfriend down at the bottom, Stephanie.
Thanks, Kevin. Yeah, hey everyone, this is Dave Bladen. I'm a cloud solutions architect at VMware. Prior to recently changing to that role, I was in the same team as Jason and Kevin, as like an NSX TAM. So I've been at VMware about 7 years now. That's my first year as a hands-on lab captain, so I'm like super excited to be talking to you today. Prior to being a captain this year, I've been a proctor and worked at HOL support at previous VMworlds. I was born and raised in the UK, now live in kind of sunny Tampa, Florida. Spare time, just enjoy traveling with my family, or at least I did prior to COVID. Hopefully we'll get back to that sometime soon. And also kind of geeking out with my kids. They're kind of big Star Wars fans, so we like going to Comic-Cons and things like that. So they're bottom right, that's us meeting some Star Wars celebrities here recently in Orlando. So over to you, Jason.
Thanks, Ed. Hey everybody, I'm Jason. I've been at VMware almost 5 years now. Started out in NSX support and then transitioned into being a network security TAM, like Dave used to be and like Kevin still is. This is my first time being a lab captain as well. I've been a proctor, an HOL attendee, and HOL support before, so it's good to be a part of VMworld in a more serious capacity. Still in Denver, Colorado, and I like reading video games and taking trips in the mountains to do whatever fun things that we can do, usually bringing the Great Dane along with us.
Awesome, thanks guys. All right, so real quick, I'd like to talk about how we construct the lab. So the team is made up of more than just the 3 of us. We've got other people that are involved, and technical marketing kind of sets the pace on what we're showcasing in these labs. So the technical marketing team tell Chris, Leanne, and James, who are kind of the lead of our group, what they want showcased. James, the one we work with most closely, then translates that and tells us what technical marketing really wants. I usually do most of the pod build out, which is the bits and bytes that make up the actual lab itself. And then we kind of validate that pod together for final approval. We fight about how big it is because it takes up so much space in the cloud from a RAM and storage perspective. And then David and Jason and myself write out the manuals, so that way we have the content for you guys to consume. We then test some more, and once we find all the broken stuff, we get that fixed, and then we do it all again for spring release. So we do this twice a year. So you'll see the use of this 3-tier app in most of the modules in this security lab. And it's really just a very simple application that consists of some web servers, an app server, and a database server that can really just showcase flow. And I like to put the topology up here because it's really important to understand how it works. So that client machine accesses over HTTPS to the web servers. The web servers then access the app servers on port 8443. And then the app servers use a MySQL database that's installed on the database server to then service that back to the client. So our lab kind of has 2 separate topologies in it. Since it's mostly security focused, we wanted to make sure that we took away all of the virtual networking components and all of the pieces of NSX that aren't necessarily required for security. So we have a 3-tier app called the Phoenix app. It's on a flat VLAN backed network. It's not using any of the virtual networking components of the NSX platform, so that we kind of just showcase the security portion. But we still have kind of the one from last year that we refreshed, which sits on 3 separate logical segments. And this is the one that I'm going to go over in the module that that I'm going to show off. So the overall lab consists of 6 total modules. Module 1 is distributed firewall and security grouping, which is the one that I'm going to walk through with you today. Module 2 is the distributed intrusion detection and prevention, which David is going to walk through today. We're not going to dive into the URL analysis, but once again, you can come back and consume this lab at a later time and do that in a self-paced manner. Number 4 is security planning with NSX intelligence, which is really cool and new this year as far as live labs go. And Jason has the honors of going through that with you guys today. We then have role-based access control, and then the NSX-T identity-based firewall modules as well. Once again, please come back and consume this lab, self-paced whenever you get a chance. So the module I'm going over today is module 1, which is distributed firewall and security grouping. I'm not going to read through this because these are the steps that we're going to go through, but basically we're going to show a functioning 3-tier app with some pre-built rules. We're going to tear the rules down. We're going to build the rules back up. We're going to verify the rules are being hit, and we're going to kind of group some objects to recreate those rules. So dynamic grouping is what I think makes NSX very powerful from a security perspective. The old traditional way of doing firewalling is you had to know what IP you were coming from and what IP you were going to, and that's pretty much how you wrote your rules. With NSX, we have the ability to use basically dynamic objects or objects that can change in the environment and write our policy around that. So with the dynamic grouping capability, we can do stuff like write security policy on logical ports, logical switches, virtual machine tags, IP sets, operating system names, computer names. And as those things change in the environment, you can then apply that security, or the security policy is automatically applied as they change. So a perfect example would be, if you build out some web servers with a particular naming convention, you can set security policy based on that naming convention. And as you deploy more web servers, as long as they adhere to that naming convention, they'll automatically be included in a security policy. So this is what it kind of looks like to build out that security policy using the dynamic structure. So first you want to tag the assets in the environment. You then kind of group those together based on the tags. And then the distributed firewall references those in order to apply the security policy. Important note is that, in the NSX environment, any machine that is protected at source or destination, firewall point needs to be on an NSX prepared port group. But as I talked about earlier, those port groups can be overlay backed networks, or they could be traditional VLAN networks. All right, David, I think that's you.
Thanks, Kevin. Yeah, so in the module we're going to walk through here shortly, I'm going to be talking about the distributed intrusion detection and prevention. It's a really cool feature. It was initially released in 3.0 of NSX-T. At that stage, it was detection only, whereas now with the latest release, we can do, as well as detection, we can also do prevention. So if you can just move on, Kevin. If you just build out a slide for me.
Oh, I'm sorry. Did that move to the next one or not?
If you can just like build out a slide, I guess I think it has animations. Just build the whole slide. Yeah. So basically, some of the challenges with traditional IPS is you typically have like a large physical appliance that sits kind of the perimeter of your network, which basically you have to hairpin all the traffic, which can create network choke points, can impact performance, and probably not the most effective way of doing IDS IPS. So with NSX Distributed IDS IPS, it's just like the distributed firewall. It's actually distributed at the hypervisor level, and we'll kind of go into that during the lab. And typically, traditional IDSs as well don't have context of the workloads. So they might see a signature bound for a machine running Apache, for example, but if they see it as a different kind of web server, maybe like IIS, that might detect a bunch of false positives and just cause more kind of headache and operational challenges. So we can take some of that context from VMware, what's actually running on the virtual machine, the operating system, the application, and tailor the policies accordingly and bring in that kind of real intrinsic security story. So yeah, next slide, please, Kevin. Yeah, if you can build that one out as well, please. Thank you. Yeah, so kind of NSX, this is the challenges solved by NSX Distributed IDS. Just as I mentioned before, it's distributed. You can basically get, we download signatures automatically from the cloud so that you can set those to automatically update. It's that context-based threat detection, right? You can really kind of prioritize what you want to be alerted on, what you want to detect, what you want to drop. And that kind of policy follows the virtual machine as well. So it's not bound to a single cluster. This really kind of opens up a use case for things like PCI, for example, maybe a lower lifecycle virtual machine. You might not want to do as much kind of inspection on, but your mission critical PCI database server, you could have that policy follow it no matter where it goes. Okay, thanks, Kevin.
All right, at this point, I recognize that I'm what's standing between you and actual labs. So let's, we'll go through this quick and we'll get to the fun stuff. So NSX Intelligence is kind of a cool additional application that you can deploy alongside NSX Manager. And what it does is it allows you to see deep visibility into your NSX environment. So go ahead and advance the slide, Kevin, and we'll, a lot like what David said with IDS, and a lot like Kevin has said with any other, DFW or all the other security components. What's cool about NSX is that we're doing all this stuff native inside the hypervisor. So when we, in a traditional approach, go ahead and advance that slide. We have all this stuff that's external to our infrastructure, right? We have components in the physical environment that are doing monitoring or visibility or security pieces. And with NSX, we're putting as much of that as we possibly can inside the virtual environment. So outside, it's rather inefficient. Go ahead and go to the next. And inside NSX, we're going to be putting it inside instead of all this components traversing to the outside. Go ahead and give me the next slide, Kevin. Cool. So, right, everything we build, we're going to build it efficiently, in path, inline, and NSX Intelligence, because it's built right next to NSX, sees all this at a visibility level that is equivalent to your NSX Manager. All the information NSX has, NSX Intelligence gets. So rather than exporting this to some external location, let's do it all native. Go ahead and advance that one more time. And with that, we get a lot of good thing. And you might say, hey, well, this sounds a lot like Network Insight or any of my other visibility tools. And that's not inaccurate, right? But what's good about NSX Intelligence is this sort of very deep level of understanding of what's going on inside your NSX environment. Network Intelligence is a good broad view of your environment, virtual, physical, if you're allowing it. NSX Intelligence gives you deep understanding of your NSX environment and allows for some security planning, which is what we're going to play out with in the lab. That's all I've got, Kevin.
All right, thanks. So now it's time to jump into the live labs. So give me just a second to stop my sharing and switch over here. All right, you guys viewing my screen?
Yep.
All right, perfect. So this is where I was able to find the lab. You just go to hol.vmware.com. You can search for 2226. And here's a quick sneak preview of O2 that we're still working on that hasn't been released yet that we can see in the background here. But this is the one that we're going to be covering is HOL 222601. Just go ahead and enroll, launch. And then what it will do is it will launch a virtual desktop for you here to do your work in, and a guided manual here on the right-hand side. You can click on table of contents. You can go to any one of the different modules. Any of the modules are independent, so you can come, consume one module at a time if you only have a little bit of time, or you can go from the beginning to the end. So I'm really just going to kind of throw this away and do this based on memory and deviate from it a little bit. But if you come back, you can go through and follow the manual end to end for 01. So I'm going to go ahead and close that, hit extend on that. I got an hour and 34 minutes. I should be able to get through it much quicker than that. I won't hold you up that long. So real quick, what this module is about is really about the security and the distributed firewall. So under the security section, under distributed firewall, we've got the different sections up here that are used for various different things, but we're going to focus on the application one today. And then we've got the security policies themselves, which are these security policies. The security policies themselves contain rule sets, and then these rule sets are the ones that are actually applied to the individual virtual assets for whatever it is that you're trying to do. So the 3-tier app is the one we're going to focus on today. So real quick, I want to show you that our final rule right now is an allow rule. And even though I do not have my rules enabled for my 3-tier web, because my final rule is allow, anything goes as far as distributed firewall right now. So I'm going to go ahead and launch that 3-tier app just to show you that it functions. I can go up here to this link and we can choose web 01 or 02. And we should immediately get this up. This is a searchable database. It works. It doesn't have a whole lot in it, but it's kind of neat. You know, it's what we use in the hands-on labs. And then we can also hit the other load balance server and get the same results. So real quick, the first thing I'm going to do is go down here and I'm going to change my very final rule from allow to drop. And I'm going to go ahead and publish the changes here. Once I publish these changes, we're now basically blocking all communication within this platform other than the specific rules that we have set for allow. So now if we go back to this customer database and we hit the refresh button, it's going to spin here for about 20 seconds and we're going to get a page timed out because we cannot access the application anymore. So real quickly show you kind of how these rules are built, and then we're going to go ahead and enable them. So every rule has, you know, about 5 different components to it. We've got the name of the rule itself. We've got the rule ID, which is automatically generated once you create a rule, and we can use that for, you know, going through and looking at it from a log insight perspective and all sorts of other things. We've got a source, so this would be the source traffic, destination, and this destination can contain all of those dynamic groups or those static groups and all of the other ones that I talked about in the presentation earlier. We have the service section, which is the service that we're going to apply this rule to. I'm going to skip over context profiles, and that's something that I believe is covered in our 02 advanced one. And then the applied to field is actually very important. Right now, I only have this applied to the distributed firewall as a whole. But what we can do is we can scope these rules down so that way they're only applied to the specific virtual assets in the environment. That way these rules don't get pushed to ESXi hosts that don't have the workload on it, and it's a much more efficient way. Once again, a little bit more of an advanced topic that we'll go over at a later time. We have a couple other options if we hit the gear here. One of them is logging, which I'm going to kind of show you how this plays in. I've got the logging enabled for these rules, and I've gone ahead and put a log label on here as well, which I'll show you is very helpful when using Log Insight. So without any further ado, let me go ahead and enable these 3 rules. Oh, and real quick, I guess the rules are, we've got the 3-tier client access. That's from any source to our specific web servers on 443 or HTTPS. We've got our web to app access. So our web servers access our application servers on TCP 8443. And then our application to database access is from the application server group to the database server group, and the database is running MySQL. So it's using that service. Let me go ahead and publish these changes. And even though this says in progress, things usually work pretty quick. So I'm going to go ahead and go back here. This was our expected result last time, and now the page is refreshed and my 3-tier app functions again. So go ahead and hit 01 and verify that that one works as well. So real quick, I want to show you a little bit about those log labels. So I'm going to jump into Log Insight here and do a refresh. Notice that we've got no hits on these 3 widgets at the moment. And if I do a refresh here, we now see that we've got some hits. So this was, you know, me accessing that application once those rules were enabled. Just to kind of dive into this real quick, and I don't want to go too deep in the interest of time, but if we click on the interactive analytics here, we can go see that this 3-tier client access rule was hit, and the way I've got my widget set up is a match pass on that basic rule ID that I showed you earlier. So this is kind of a quick way to come in and see whether or not your rules are actually being hit in the system. So now let's just go ahead and delete this entire security policy, and we're going to go back and build it from scratch real quick. So if I just click the three dots here and say delete policy, and go ahead and publish that, and do a refresh down here at the bottom, now my entire security policy is gone. Now I would expect that if I went back to here, because I don't have any explicit rules allowing this application to function, and hit the refresh button, we will have that same behavior where we're not going to be able to reach the application. All right, so let's go back in and build the security policy back up. Before we do, I want to quickly go over the grouping and tagging functionality. So if we come into our inventory section and into groups, pre-built this three groups here. So the 3-tier app servers, the 3-tier database servers, and the 3-tier web servers. I'm going to explore the 3-tier web servers with you real quick, and then we're going to delete the 3-tier database and 3-tier app and rebuild those from the ground up. So if we go explore this 3-tier web, I will show you the way I've got this set up. So if we go look at criteria from the presentation earlier, this is where you can control what assets are part of this grouping mechanism. The way that I've got this set up is I have tagged the 3-tier web servers with a tag called web, and I've also tagged all of the 3-tier app servers with a tag called 3-tier. So what I'm doing here is telling the system to match this tag and this tag, and if any VM within the environment consists of both of these tags, then go ahead and automatically add it to this group. The benefit of this is, let's say I want to roll out a 3rd web server in the future. All I need to do is deploy that web server, tag it appropriately, and then it's automatically included within this group. I guess instead of deleting these groups, let's just go ahead and edit them. So the database server, we'll go ahead and edit this guy. And it was set up very much the same way, where I had 3-tier and database. But what I want to do is go ahead and actually delete that. Did I go ahead and edit? You know what? Let's just delete them. It'll make it a lot easier. All right, so I've gone ahead and deleted the app servers and the database server groups. So let's build that app server group back up. So we'll say add group and 3-tier app. And we'll go ahead and click on set members. So before, what I did is I added that criteria and chose the tags. Instead, I want to show you how you can statically assign something. So we'll just go to members, do the drop down here to virtual machines, and then I can just directly select that app server. So that app server is now in that group forever. It's not dynamic, nothing else will be automatically added or removed, but this app server is now in that group. So now let's say your database server is not inside the NSX environment, for example. So let's say we've got to, apply source-based firewall policy on an asset that's external to the NSX system. So let's go ahead and create the database server and kind of assume that it is external to the system. So we'll do database servers, click on set members. And instead of using my membership criteria or members, I'm going to go ahead and put the actual IP address of the database server in. So I happen to know what that IP is. It's 172.16.30.11. I'll go ahead and apply that and go ahead and save that. So you can also quickly come in here and click on this View Members button to see what's in there. In this case, it is only IP addresses, so you can't really tell what virtual asset it is because I chose the IP address. But for example, if we go to the app servers and View Members here, we can see that app 01A is included in this group. So that's basically grouping and tagging in a nutshell. So once we have our groups together, now we can go create or recreate our security policy. So if I go back to security and to distributed firewall, we go ahead and add a new policy. And we'll call this policy 3-tier app. So once I have the policy, it's really just an empty shell. There's nothing inside. So I can click on my 3 dots over here again, and I can go ahead and add a rule. So the first rule, and I know that the flow is, we'll call this client access. And I know that I want to leave my source as any, because I want any user or any application to be able to come access this application. And the destination is going to be that web server group that was dynamically created. So go ahead and click on the little pencil there, and I can come down and I can select the 3-tier web servers as my destination. Go ahead and hit apply. And then the service, I want to use HTTPS because that's what I'm accessing those web servers on. So I come in here, got a nice search bar. I can just type in HTTPS and do a quick search for me, and I can find the HTTPS service here. Go ahead and apply that. And now that rule is basically complete, minus the applied to, but I'm going to skip that for this lesson. So now once the client talks to the web server again has to talk to the application server. So let's go ahead and create another rule. And we will call this web to app access. So in this case, I actually have a source, which are my web servers. So I'm going to go ahead and hit my pencil button here and go find my web servers group, which once again, we talked about previously is built using dynamic tagging. And our destination is going to be our application servers, which remember we statically assigned the application server into this group. And if you remember from the drawing, our service is a made up TCP 8443 port that we've already got created within the environment. So it kind of pops up here at the top. So we put the underscore in here. All right, so the last rule that we need in order to make this app work is the application server needs to talk to the database server. So let's go ahead and add one more rule here. And we'll call this rule app to DB access. This time, of course, our source is going to be the application server talking to the database. So let's go ahead and search and choose our application server, which remember is made up of a static group. Our destination is going to be the database server group, which again, just contains an IP address for our purposes today. So go ahead and search and find the database server. And then the services here, we're running a MySQL database on the database server. So if I come in here and just type should find the MySQL service right here, which is TCP 3306. Go ahead and apply that. So now we have our client access, web to app, and app to DB. And assuming that I did everything right, once I publish this, we should be able to access our application once again. Once again, it says in progress. Things tend to work pretty quickly in here. So let's go ahead and refresh. And hey, look at that. I guess I did it right. Awesome. All right. So one last thing I want to cover, and that is a way to kind of troubleshoot what rules are being hit in the environment using the NSX-T platform, not necessarily login site, which is the outside looking in. So if you noticed, I didn't set logging on those rules. However, we've got a nifty little tool in here under plan and troubleshoot called TraceFlow. And TraceFlow is very powerful because you can basically test communication from one virtual asset to another virtual asset within the environment using lots of different protocols, lots of different ports, and really kind of see the end-to-end packet flow, from the source to the destination. So let's test web to app, for example. All right. So I know that I want it to be unicast. I want it to be TCP. And our destination port is going to be 8443, which is that web to app. So let me go ahead and type in 8443. And now I can test from any virtual machine to any other virtual machine within the environment. So let's select Web 01, for example. So if we go to Web 01A, will be our source machine. And then let's set our destination as App 01. So the expected result here is going to be that the traffic's allowed, and it's going to show us the path all the way through because we have that rule in place. Go ahead and hit the trace button. All right, so it looks like it was delivered successfully down here at the bottom. And the cool part is that it gives us a graphical overview of all of the steps that that packet took through the environment. So we left the web server, we went to the LS web logical segment, we went to our T0 gateway to get routed, we came back to the LS app segment, and then it was delivered to app 01, which is awesome. And then we've kind of got a listed view of all of the steps that that packet took in the process. So now what happens if we try to trace something that's actually blocked by the distributed firewall? So let's edit this real quick. And I don't know, let's pick SSH, for example. So we'll use port 22 as the destination port. And since we don't have an explicit rule that allows port 22 traffic from web to app, our expected result here is that we're going to be blocked by the distributed firewall. Go ahead and hit trace. And there we go, it's blocked. I do want to point out a very interesting note here is that because the NSX distributed firewall is at the virtual NIC level, it firewalls all outgoing traffic and incoming, so egress and ingress traffic. So if there's not an explicit rule that allows that traffic through the network, it essentially will never leave the virtual NIC or the virtual port of that virtual machine within the environment. So the cool part about this is if it's unintended traffic or traffic that you're not wanting to allow in the environment, it never even gets put on the wire, hardly gets put in the virtual service, and it gets dropped directly there at the virtual machine within the system. So, all right, that pretty much concludes the entire lesson from module 1. So at this point, I'm going to go ahead and pass it over to David and let him go through module 2. Thanks for listening.
Thanks, Karen. Great stuff. Let me share my lab out here.
Look at that, it worked the first time too.
There you go. So hopefully, can you see my screen?
Sure can.
Great. Yes. So let's just go ahead and enable the IDS right now. So it's pretty simple. It's enabled at the cluster level. So I'm just going to go down to Distributed IDS. It's the same kind of UI, just a different section. Like Kevin was talking about the distributed firewall. I'm going to be using the Distributed IDS down here. Click on Get Started. And it's enabled, like I mentioned, at the cluster level. But before I do that, you can see here that this is the latest state. We downloaded the signatures. You can auto update. The hands-on lab environment is not connected to the internet, so this is not going to work. But in your guys' production environment, in your own office, you can click this auto update to just automatically get the latest signatures. And you can see right now there's a count of over 13,000 signatures. So I'm just going to enable it on this compute cluster. The lab is built up with a management cluster for the management appliances, and then the compute cluster is where we house all the general workloads. So it's just as simple as toggling. You sure it'll enable? Yes, and there you go. At this point here, IDS, IPS is enabled. So let's start going out and building some actual policies and rules, okay? The first thing we want to do is create a profile. There's a default one, but I'm going to create our own one. I'm just going to call this all serve policy. If you recall, at the introduction to the workshop, we mentioned how we have context awareness of what the virtual machines are running. So for this example, I'm just going to select everything, but you could select, I just want to know about critical events, high, medium, low, attack types, and you can also go down to products affected too. Remember I was giving an example of IIS, Apache. You could specify, an example here would be, if you're running some desktops that are running Windows 10, why would you even have signatures for Linux apply to those? Because they just don't apply to the operating system. So you can get real granular with the config. You can kind of design this however you like to meet your needs. I'm just going to leave it as a default now. So we're going to be looking for every single level here. I'm just going to hit save. And now we have our policy defined for IDS, and you can have multiple different policies. Kevin was talking about tags in the previous section. You can apply tags to these as well. But I'm just going to go ahead to rules. So one thing you'll notice, this should look pretty similar to you from what Kevin was showing a few moments ago. It's the same kind of interface to create rules for IDS, IPS, just like it is with the distributed firewall. And something that's really cool feature too is, Kevin mentioned all the groups, kind of walked you through that process. You can leverage those same groups in the IDS, IPS engine as well. You don't have to recreate the wheel there once you've already created them. So I'm just going to call this IDS. Let's go ahead and create a rule underneath. In this example, I'm just going to call it IDS all sev. And you recall, so you could get really granular here. You could specify, I only want to, for this particular rule, I just want to look at certain sources, certain destinations. So maybe in that example before, here's all the groups, right? I don't have to recreate them. So here's the web servers that Kevin created in the previous module. But I'm going to cancel that. I'm just going to apply this to everything that's on the DFW. You're going to select your IDS profile. In this case, this is the all sev policy we created a moment ago. And you can see it's successful. You know, if any time you see something that shows up as in progress, you can just mash this little refresh button and it should turn green momentarily. I'm going to go ahead and save that. And you can also leverage the apply to field, just like you can with a distributed firewall. That kind of just limits the scope of where you apply the rules to. And as your environment grows, that's something you should definitely consider and look into. But for now, I'm just going to leave it, everything else is the defaults. And it's not specifically covered in in lab 1, but Kevin mentioned that lab 2 for NSX SecOps should be published here in the near-term future. That will cover also detecting and preventing, so the IPS portion. For this lab, we're just going to look at the IDS, but this is where you go to set certain rules if you wanted to prevent the traffic from occurring. So I'm going to leave it as detect for now. You know, you can enable, disable it if you wanted to as well. Here's where you could add those log labels that Kevin was showing previously. So I'm just going to leave login disabled for the purpose of this demo. Just go ahead and publish it. You can see I've got 2 unpublished rules. Oops, extend my time. So now already the rules have been realized, and because it's distributed, this policy has been pushed out to all ESXi hosts that are part of that compute cluster, right? So what I'm going to do to simulate some traffic, we've got a script here that's going to simulate some kind of bad network traffic. So I'm just going to go ahead and run that. While it's doing that, I'm actually going to show you, this just takes a couple of minutes. Let me log into one of the ESXi hosts and I'll actually show you some commands you can run and kind of confirm that everything's working as expected from the host level. So if I log into ESXi 01, this is one of the hypervisors in the compute cluster. To maximize that. So what you'll notice here, you see how it didn't complete. There has some kind of autocomplete. So I just did the NSX CLI. That's it. Once you install and enable NSX on an ESXi host, it also includes the NSX CLI. So you can run kind of NSX related commands directly from the CLI here. You know, here's the command I want to run. I want to get, and I want to actually get the IDS engine. So if I want to actually look now, maybe the status, I can just hit up the up arrow, type engine, and I can status. You can see that it's enabled, how long it's been up. If you want to do some additional things right now, hopefully we might start seeing some statistics here. So if I just back out a little bit, go change it to events, stats. Let's see if we're starting to see anything already from that script we're just running. Oh, if I can type. It helps if you actually type the command correctly. There we go. There we go. So we're already starting to see the event counts crop up. So you can see right now, the IDS is seeing 62 critical events. And what we can actually do now, let me take you back to the UI. So over here, if we, within the same instance here, if I click on events, what you'll notice now is we're starting to see some things in our environment. And again, you can kind of, right now, there's like 17 unique intrusions. And you can see in total, here's all the different intrusions. If I just want to filter that, I can see there's 13 critical. There's 4 that are high. I'm just going to filter this. So right now, you're only going to see the critical events. And if you want to expand on them, you could go up here. You could filter by attack type. Maybe if you want to certain by like attack type or CVSS score, that's a security way of identifying and kind of giving priority to certain vulnerabilities that are out there, the CVSS score. So maybe you just want to filter by 10, which would be the highest, right? The signature ID, the virtual machine name. But I'm just going to pick one here. So I'm just going to pick the top one. And as I expand out, you can see it gives you some details about what the actual signature was. In this case, it's a Trojan for Windows 32. You can see the attack the client virtual machine where it's coming from. Here's the IP address, what the port was, how many bytes were set to the client. The attack direction, notice the arrows from the attacker to the target, traffic flow direction. You can see what the target server was. Right here, you can kind of get a little graph of what's happening. If I actually click on this, it'll actually show me a bit more about the intrusion history. There's the signature ID. It's kind of classified as critical. And you can actually see the virtual machines that were affected. If you remember, I'm running this from that core A virtual machines where I ran the script from. So you can see how many attempts, the source IP address, destination IP address, etc., etc. So it's pretty powerful. You can get explicit detail of what you're looking for. Let's continue to scroll down. You can see the total amount of attempts that have been for this particular signature. And again, if I wanted to filter this, if I just select everything, if I wanted to filter it by products affected, if I just select Windows, apply, it's just going to show me specific events in the environment that have been that would impact Windows. So it's pretty powerful, and you can kind of tie this in so you can get like if you wanted to change it. Let me go back to my rules here. We're kind of at this point now that I've done my initial pass, I can go back and set this to detect and prevent. I could rerun the script. And at that point, it should kind of block the traffic. Just one thing on that, as well as setting it to detect and prevent here on the individual signatures as well. You also want to set that to drop as well. So if I go back to the settings here, if I click on the signature set, if I wanted to, for example, if I'm just going to pick this one, you notice the default action is alert. If I wanted to block this particular signature as well, I'd set it to detect and prevent in the rule policy, and also for the specific signature, I'd set it to either drop or reject, depending on what I want to do there. So that's just real quick. As far as the actual IDS IPS goes, again, the second lab that will come out soon will actually walk you through more of an attack scenario of running an attack, seeing what it looks like to actually detect and prevent. But that's just a real quick overview. Hopefully you can see how powerful this tool is and how it can really complement the distributed firewall as well to add additional security to your environment. So with that, I think that's all I wanted to show you. This definitely take the lab in your own time, run through it, and hopefully you find it useful. I'm going to go ahead and pass it over to Jason.
Thanks, David. All right. So I'm going to talk to you all about the NSX intelligence. So much like David and Kevin have already sort of talked about in our presentation so far, is the distributed firewall stuff. And I've sort of cleaned up this distributed firewall specifically for the sake of showing off what NSX intelligence is going to do in recommending a 3-tier app design like Kevin built. So you can see here in this environment that I don't have any other distributed firewall rules besides a 3-tier app for comparison, but I don't have any of these rules enabled. Instead, we just have our default and our default allow. So right now we should be able to get into our customer database. We can refresh this, access is still good, no problems. So we can get here, no problem. But what if we actually wanted to have NSX intelligence recommend some rules for this 3-tier app for us? So what we're going to do, we're going to go to our plan and troubleshoot, and can actually go to our recommendations. See, I have not been here yet. It's telling me all about the cool things that we can do here. So let's go to our recommendations. So discover and take action, kind of neat. It's going to give you a lot of an overview of your entire environment and sort of a neat map. Recommendations, since we've been doing so much 3-tier app communications in this environment, it actually has a setup here for us. So we can sort of look at this 3-tier app. And it's given that NSX intelligence is running in this environment, it's viewing all of the flows that are going through NSX, and it says, hey, I see that there's a 3-tier app. I have, 4 virtual machines that are communicating to each other very commonly. So I'm going to recommend you 3 rules, group, and no specific services that we can allow this traffic to communicate. So if we click into the 3-tier app, sort of see what it is that it's talking about and what it's going to recommend to us. You'll see first off, we get this nice little view, this cool visual of what's going on. We basically have any access to this group 2 and group 2 to this app and then app to DB. So this is a nice way for us to see visually what kind of communication is going on here. It's not the thing that was in the slideshow prior to all this that has, you know, the actual ports and everything. It isn't visualized here, but we have that all written down here in these suggested rules. So we can go, you know, here's the 3 rules it's recommending, and it's also recommending a group. So the group thing is really what's troubling me about this, just because NSX Intelligence, as smart as it is, isn't giving us a very intelligent name, in my opinion. I would want to rename this group. So I'm going to edit this real quick. And we'll just, you know, we know that our NE to group 2 and group 2 to app, well, that's pretty familiar to us at this point. I think that that is probably our 3-tier web servers, right? And we can change our description. I'd actually like to rename this something a little more dynamic. So we'll call this created by NSX Intelligence. We can also look at the set members in here, and we can see what we've been going on for our traffics. So here we can see that it's already pre-populated Web 1 as a communication. We had been accessing via Web 1, so that makes a lot of sense. So let's add Web 2 because we know it's a part of this application 3-tier app. Excellent. So we can save that. That looks good. At this point, we could go ahead and go to the proceed, but something about those rules, the name and the policy name, I'm not a fan of this. I like to be able to read the firewall and understand exactly what's going on. So let's see what we can do about this. So we can rename this to be, yeah, this is our 3-tier app by NSX Intelligence. All right, and then I can tell just by the names here, by the services here, what these rules really should be. So, you know, our service is HTTPS, it's NE to web. You know, we know that this is our client access rule. So I can change that, and we can edit this real quick. So we have client to web, right? And then we have web to app. So let's rename that so it makes a little more sense as well. And our app to DB, right? Perfect. So at this point, we can review this, and then we can actually proceed to publish this to the distributed firewall outright. So if this all looks good to us, we can see that you know, we have our names, they're a little more clear than they were before. We can see that our NE to web, web to app, app to DB, all our services look correct, and we're applied to our 3-tier servers. So this is something I really like, is that the NSX Intelligence has helped us to not just apply every rule to everything in the distributed firewall. It's being a little more granular and saying, you know, we have 4 VMs in this group. I recognize this group. We should be applying these rules to just these VMs. You know, a different virtual machine elsewhere in the NSX environment doesn't need these rules. We want these rules specific to these VMs. And we want this traffic allowed. And we want these rules enabled. So you can go ahead and click on proceed, and it'll give us a nice preview of our new distributed firewall list as it would be. So remember, as I had it before, we had our 3-tier app, which looks like this, but none of these rules are enabled. And we have the newly created 3-tier app by NSX Intelligence. So something I like about this little area here, much like the distributed firewall, you can actually, you know, drag and drop and move things around. I'd prefer just to have this right here in the middle so I can do a nice stare and compare once this has been published. So you can double check your rules once more, make sure everything looks good, and then we can go ahead and publish. So we'll make sure we want to recommend, you know, publish these recommended rules. We'll say yes. Shouldn't take us but a moment. And now we can go look at them in the distributed firewall. So we're back at our distributed firewall, and we've built out a new policy with 3 rules inside of it. You can see, you know, as Kevin mentioned, it's in progress, but pretty quickly this is going to be a success. So we have these rules, and we have these allowed. So at this point, of course, we should still be able to access Web 01, no problem. But if we take our default rule and change this to a reject or a drop, then publish our changes. So now our default traffic rule says we're not allowed to do this. So if the traffic isn't explicitly allowed by a rule in here, then it won't be allowed in our environment. So we're rejecting our traffic at our default rule because we do a good firewall here. We do not have these enabled, so we're not using Kevin's built list. We're going to do these the NSX intelligence way. So with these enabled and our defaults finished, this should still work. Awesome. We can double check that we can also get to WebO2. Excellent. So yeah, that is our NSX intelligence and creating rules for us. It needed a little cleanup to make sure that it was human readable, but it's a good way for us to get a good understanding of how NSX intelligence can recommend firewall rules for our NSX environment. So,
awesome. Thank you, Jason and David. Very good.
Thanks, guys.
Go ahead and share the end of this PowerPoint presentation and get things wrapped up. But thank you guys so much for all your hard work this year. It's been great working with you guys, and I'm sure we will enjoy working together for the rest of this year to go ahead and continue on building these out. All right, I see my screen again.
yep.
All right. So just a reminder to everybody watching this video, please take your survey. There's also a survey at the end of each one of the hands-on labs. Feel free to give us some feedback. If there's something you think we should have covered that we didn't cover, or you find some misspelling or something else that we messed up in the lab, we want to know about it. We want to get it corrected. If you also enjoyed the lab and loved it just the way it was, we'll take that feedback as well. So thank you guys all for watching. I really appreciate it. Thank you again, Jason and David, and everybody have a great day.
Thanks, everyone. Bye.